Hey physics friends, Mr. Collier here. I want to give you some helpful hints for the collisions lab using the Pasco's SparkVue software. First thing I want to do is remind you how to rename your runs. So in the bottom right hand corner there's a screwdriver and a wrench. If you click on that, that brings up these tools, and you click on manage runs, you can actually rename some of your runs. So for example, the first thing I did was an elastic collision, so I'm just going to call that elastic 1, and I can use my lab paper to remind me what that's called. And now you can see that run number 1 has been renamed elastic 1. The next thing I want to show you is how to interpret some of this data. So if I'm looking at this blue line on the left hand side, I can see that it jumps suddenly from 0 up to a number. So that first jump is actually just you pushing the car. So what I want to know is how fast was it going just before it collided, and that's actually going to be the right hand side of the high points here. That's going to be just before it collides. So for me, that's 0.72 meters per second. And again, not the very height of the peak, but just before it dips back down, because that first peak is me pushing it to its speed, and then it coasts for a little bit, and then just before it jots back down to 0, that's what I'm seeing as just before it collides. Again, right over here is me accelerating it, but then right over here is just before it collides. This dip is the actual collision slowing it down, and this is right after the collision. On the right-hand graph, this is it sitting there, not moving before it collides, and then right here, its initial peak is what happens right after it gets hit by the other car. And that analysis is similar for your other runs. So for example, this is another elastic collision here, but it's a different one. In this one, both of the cars were moving, right? So I pushed it and it started moving, then it coasted to this point right here, which is just before it collides. Then it sharply comes down, and then this is just after it collides. So those two data points that we need are like right there-ish and right there-ish. Conversely, on this other car, I pushed it, then it coasted, and right there is the data point we need just before it collides. The collision makes it change directions, and this is the speed right after it collides. One last example, this is an inelastic collision. So again, we push the car, it starts moving, it coasts for a little bit, and then we have the speed just before the collision. The collision is another sharp line, and then after the collision, we actually want to grab kind of the first data point when it starts to do this little slowing down, because after the cars slam into each other, they're going to start coasting, and friction is going to slow them down. So we want that first point after the collision. And actually, in this one, if you look, the speed on this graph should be the same as the speed on that piece of the graph, because the cars collide, stick together, so they should be moving the same speed. When it comes time to crunch numbers, you're going to want to set up some sort of spreadsheet. You can do it by hand if you want, but you're going to have to crunch a lot of numbers. So from the graph in SparkVue, you're going to get the initial and final speeds for the red car and the blue car. So like how fast was it going before it collided, how fast were they each going after they collided. That's kind of your raw data, and you get that again from SparkVue. You also need to have the mass of the car and the added mass as well. Now from there, you can just scroll down on your spreadsheet, or you can do another tab, whatever you find easier. And there you're going to have momentum and then eventually kinetic energy. So for momentum, you need to do mass times velocity. So you can, like I showed you in class, kind of click on a cell and tell it what to do. Tell it to multiply this velocity by this mass, or tell it to, for total momentum, tell it to add the two momentums together. So you want to play around with equations, and I can help you with that if you need it. Finally, you'll also do the same thing with kinetic energy, 1/2 mv squared. So again, you're just using those velocities from the SparkVue data. and you're adding them together to get the total energy. And what you should find is that kinetic energy is mostly conserved during an elastic, but definitely not conserved during an inelastic. Good luck. Let me know if you have any questions.